Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problem number 4 of the 2003 AP Calculus AB pre-response question, which focuses on the graph of f prime. Okay, problem 4 is as follows. It says, let f be a function defined on the closed interval -3 to 4, with f of 0 equals 3. The graph of f prime, the derivative of f, consists of one line segment and a semicircle as shown above. So this is the graph of f prime. Very important, okay? You need to look at what you're given. This is the graph of f prime, not f. Question A. On what intervals is if any, is f increasing? Justify your answer. All right, so in this question, we're going to be connecting f with the graph of f prime. All right, so to do this, we're going to go ahead and draw our heart of calculus, f prime, and f double prime. All right, plus or minus, plus or minus. So these are the signs right here in the center. Let's go ahead and connect the behavior. So the sign of f prime determines if f is increasing or decreasing. All right. The sign of f double prime determines if f prime is increasing or decreasing. And then the sign of f double prime determines if f is concave up or concave down. Okay, so that's basically how the signs determine the behavior, or how the behavior impacts the sign. All right, so in this problem, we are connecting f with f prime. So using this heart of calculus graphic right here, this is the rule that you need to remember. If f prime is positive, okay, if f prime is positive, guess what? F is going to be increasing, okay? So if f prime is positive, then f is going to be increasing on that interval. And if f prime is negative, then f is going to be doing what? Guess. F is going to be decreasing on that interval, okay? So if f prime is negative, then f is going to be decreasing. All right. In this problem, we ask, where is f increasing? So we're going to be looking at the first rule right here. So when you ask where f is increasing, if you want to use f prime to answer that question, you're going to be looking at the sign of f prime. Mainly, we're looking at where f prime is positive. Okay, so to rephrase the question, what we're actually looking for is want to find what interval on this function where f prime is positive. If we can identify that interval, then we can conclude that f is increasing there based on the rule we just considered. Okay, so this is a graph of f prime. Let's go ahead and break it up. If you are above the x-axis, so let's do above, on, and below. Okay. All right. So for above, let me change something real quick. As any region above the x-axis, f prime is greater than 0. Okay, so that's above. If you are on the x-axis, f prime is equal to 0. And if you're beneath the x-axis, this region right here, f prime is less than 0. Since we're looking for where f prime is positive, we're focusing on the portion of the graph where the function f prime is above the x-axis, okay? So from -3 to 2, you can see, let me change the color. You can see that f prime is positive, positive, positive. And then at this point, it's 0. So the function is neither increasing or decreasing there. And then on the remainder, so you go negative, negative, you go under negative, 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 all the way to 2. At that point, f prime is 0. And then it goes back to negative again. All right, so negative, negative. So just to talk about the behavior of f, using this sign right here, so f is increasing here. and it starts to decrease, 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 and then is neither increasing or decreasing here, and then it goes back to decreasing again. Okay, so that's basically what's going on. All right, now where is f prime positive? F prime is positive on the interval from, let me show it to you, from -3 all the way to -2. Okay, on that interval from here to here. Okay, let's be careful here. So at -3, f prime is positive. At -2, it's 0. So we're going to go from -3, everything included, all the way to, and exclude -2 because it's not negative. I mean, it's not positive, it's 0. Okay, so this is where f prime is bigger than 0. Okay, so let's go ahead and write down our answer. F is increasing on the interval. You can write it using interval notation, -3, 2, or you could use inequality notation. -3 less than or equal to x, and x is less than 2. Okay, now writing this down, identifying an interval where f is increasing earns you 1 point. All right, you have to provide something else. Let me show you in a second. So you get 1 point just for stating the interval. But if you look at the question, they said justify. So anytime you're asked for justification, you just want to state the calculus that supports your answer. Okay, so just use the rule that we wrote right here. F is increasing on that interval since f prime is greater than 0. Or you can say f prime is positive for this interval. Okay, so when f prime is positive on any interval, then the function will be increasing on that same interval. And don't forget to box your answers so it's easy for the person grading your exam to zero in on your final result. Okay, so that the interval gives you 1 point, and then the justification y gives you another point. Total of 2 points in this question. All right, let's take a look at the B part. It says find the x-coordinate of each point of inflection of the graph of f on the open interval, -3 less than x less than 4. Justify your answer. Okay, so in order for us to determine where the point of inflection is or are, there are 3 different ways that we could do it. Okay, we can find the point of inflection using f double prime, f prime, and f. Okay, in this case, we are dealing with the graph of f prime, so f prime will be the method of choice to determine the point of concavity. All right, I'm sorry, point of inflection. So before I go over the rule with you, let's take a look at our part of calculus again, just to help you see the connection between the different parts of what we're doing. Okay, so f prime and f double prime. So when f is positive or negative, when f prime is positive or negative, f is increasing or decreasing. When f double prime is positive or negative, f prime is increasing or decreasing. When f double prime is positive or negative, f is concave up or concave down. Okay, so that's the connection between the signs of f prime and f double prime and the behavior of f and f prime. All right, so these are the rules for concavity. Rules for concavity, not concavity, point of inflection. Wonder why I keep calling it that. Okay, rules for point of inflection. Sometimes it could be 1 point of inflection. Okay, as I indicated earlier, there are 3 of them, 3 ways you can find your point of inflection. The first one, all right, so condition 1, point of inflection, I'm going to call it POI. Point of inflection occurs where f double prime changes sign. Okay, where f double prime changes sign. So either if it goes from positive to negative, or from negative to positive. All right, so that's how you can use the second derivative to determine the point of inflection. You're looking for the sign change. Another way you can find a point of inflection, QI, it occurs where the first derivative changes behavior. Okay. So what am I talking about here? Changing behavior, I'm talking about where it changes from increasing to decreasing, or where it changes from decreasing to increasing. So wherever it changes its behavior, then you have a point of inflection there. And then lastly, point of inflection occurs where the function changes concavity. Okay, where it changes concavity. When I talk about change of concavity, I mean where it changes from concave up to concave down, or where it goes from concave down to concave up. All right. So when there is a complete change in concavity, then you know for certainty that there is in fact a point of inflection. Okay. So let's go back to the graph. So out of these three right here, which one are we going to be using to determine our point of inflection? We have the graph of f prime. So we're going to be using the second rule, okay? So the second rule tells us that where a point of inflection occurs where f prime changes behavior from increasing to decreasing or decreasing to increasing, okay? So let's look at this graph and identify intervals where it's increasing and decreasing, okay? From left to right, f prime is decreasing from -3, decreasing, decreasing, decreasing. And then here is neither increasing nor decreasing. And then it switches to increasing here. So increasing, 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 increasing. And then here it switches to decreasing, decreasing, decreasing. Okay, so notable point. At this point right here, there is a change in behavior. All right, f prime changes from decreasing to increasing. Okay, that's important. It's relevant to this question. That's at x equals 0. And then guess what happens up here? The same thing, there's a change in behavior. Okay, f prime changes from increasing to decreasing. Okay, increasing to decreasing. So what happens at these 2 points where f prime changes behavior from increasing to decreasing and decreasing to increasing? These are your points of inflection, okay? So let's go ahead and identify these values first, this point of inflection, and then we have to provide justification because we're asked to do so. All right, so the points, change the color. There are 2 of them here. The points of inflection occurs at x equals 0, right here, x equals 0, and x equals 2, right here. Okay, x equals 2. So writing this down, identifying the values, the points where the point of inflection occur, you are going to earn yourself 1 point. Okay? In order to get full credit, you have to provide justification. What's the calculus that leads you to this conclusion right here? So that's the because part. All right? Points of inflection occurs at x equals 0 and x equals 2 because f prime changes from decreasing to increasing at x equals 0 and increasing to decreasing at x equals 2. Okay, so that's a justification that they're asking for. So writing that down will earn you your second point, total of 2 points for this question, all right? And don't forget to box your final answer so that it's easy for your grader to zero in on your final result. Okay, let's take a look at part C. It says, find an equation for the line tangent to the graph of f at point 0, 3. Okay, so the formula that we're going to be using here, let's take a look at that formula. This is formula of a tangent line, okay, equation of a tangent line. It's your basic algebra 1 point slope equation of a line. Y minus y1 equals mx minus x1, where the calculus comes in the determination of the slope, because you have only 1 point, where m is equal to the derivative y prime of x. Okay? All right, now let's go ahead and apply it to this problem. So we have the point under consideration is 0, 3. With calculus, with just 1 point and the slope, with 1 point and the function, you can actually determine what the equation of the tangent line is, okay? So we have the point, so this tells us that x1 in this equation is 0 and y1 is 3. So we have x1, y1. Now the slope m at x equals 0 is y prime of 0. Okay? So that's what m is. We're picking x equals 0 because that's the point of tangency that we're looking for. All right, so what is the derivative? What is y prime of 0 or f prime of 0? Take a look at this graph right here. Now it's easy to get this confused. You might say, oh, you know what, it's undefined, so we might have x equals 0 as our tangent line, but that's wrong. This is a graph of f prime or y prime. So it tells us the value of y prime at any x value. So when x is 0, what is f prime? -2. So y prime is -2. Okay, so this is exactly what the slope is based on this graph. So the graph tells you explicitly what the slope value is. You don't have to do any calculus or calculation. You just read off the y coordinates of the specified input value or x value. Okay, so there you have it. You put everything into the point slope form of the equation of a line. So we have y minus y1 equals m is -2, x minus x1. And you can leave your answer in this format. If you want to convert it to slope intercept form, make sure you do it correctly or else you lose all your points. You get absolutely nothing, okay? In this problem, you get exactly 1 point for accurately writing down your tangent line equation, either in slope intercept form or point slope form. All right, let's take a look at question 4D. That says, find f of -3 and f of 4. Show the work that leads to your answers. All right, so let's take a look at the formulas that will guide our problem solving process for this problem. So formula, well, actually, they're going to be, just a formula. First one is the fundamental theorem of calculus, part 1. F of b minus f of a is the integral from a to b of, careful here, f prime, okay? F prime of x dx, not f. So you find the antiderivative of f prime, that's f. You evaluate it at the top minus the bottom. Limits of integration, f of b minus f of a. FTC part 1. Okay? All right. And then we also need to remember a rule concerning what the integral represents. So the integral from a to b of a function, graphically, what on earth does that mean? This is the area between f and the x-axis, okay? Axis from A to B. That's the graphical interpretation or representation of the integrable function given the graph of that function. Okay, all right, now let's go ahead and do the first one, asking two questions. We're to find f of -3. Okay, so we have f of b or f of a, doesn't really matter. We need another point to do it, okay? And that comes from the initial condition that was provided for us, which is that f of 0 is 3. Okay, so that's the missing piece. So let's put that in there too. So find f of -3 using the fact that f of 0 is 3. Without that piece, it's impossible for us to do it, okay? So let's identify what a and b are. It's good practice to call the bigger input value b and the smaller one a. Or you could do reverse, but it's still the same thing. But I just want to stick with convention here. A is the smaller of the two, and b is 0. Okay, so let's rewrite our fundamental theorem of calculus, part 1. The formula we wrote above, f of b minus f of a is equal to the definite integral from a to b of the derivative of f dx. All right, so we know what a and b are. So f of 0 minus f of -3 is equal to the integral from -3 to 0 of f prime of x dx. Okay, let's see. F of 0, we know what that is. That's 3, right? So 3 minus, this is what we're looking for, f of -3. Now this integral right here from -3 to 0 of f prime of x dx, look at this. This is a graph of f prime. So when we're looking for the integral of this, what we're looking for is the area between the line and the x-axis. So we're looking for this area right here. Let's call this 1 and 2. Okay, we're looking for the area of those two regions right there. That's what represents the integral, the definite integral. So let's make boundaries for this now. So we're looking at this area right here, and then this area right here. All right, so let's go ahead and do it. We're going to break it up into two intervals, okay? All right, so what we're going to have, let me just move stuff around so I have enough space here. It's going to be -3 minus f of -3 equals the area of region 1 plus the area of region 2. All right, so this is region 1 and this is region 2. Let's go ahead and compute your individual areas. We know what the area of a triangle is, right? 1/2 base times height. So the area of region 1, A1, using 1/2 base times height, is going to be 1/2. The base is 1. The height is +1. All right, so this is 1/2. Area of region 2 is 1/2 base times height. Now, can you ascertain why I'm writing the area of 2 in red? Well, that color indicates negativity, okay? Do you see why the area of region 2 is negative? Well, it is because it resides underneath the x-axis. So areas underneath the x-axis have a negative sign to them. Okay, so I'm going to do 1/2 base. Base is what? 2 times height. I can either put a negative here and keep all the measures positive, or I can negate the component that goes underneath the x-axis, which is the height in this case. So I'm going to do that. -2 right here. But your answer must be negative, okay? All right, so when you evaluate this arithmetic expression, you will end up with -4/2, which is just -2. Okay, so that's area 1 and that's area 2. So let's go back to the equation. 3 minus f of negative 3 is equal to 1/2 minus 2. Okay, we just put it 2 over 1. 3 minus f of negative 3, 1/2 minus 2. Just carry out the subtraction. You get negative 3/2. You can just write it as 4 over 2 and subtract. So negative 3 over 2. And then you subtract 3 from both sides. So you have negative f of negative 3 is equal to negative 3 over 2 minus 3. Put that over 1. You can find the LCD. This becomes negative 3 over 2 minus times the top and bottom by 2. Okay, so you have the same denominator. What do we have here? 3 times 2, 6 over 2. And then you have negative f of negative 3 is equal to negative 9 over 2. Multiply both sides by negative 1. F of negative 3 is equal to 9/2. That, ladies and gentlemen, is your first answer. Okay? All right, let's take a look at the second part. All right, so for this one, we're going to be using the same formula and rule as we did for the previous one. We're just looking at a different interval. That's the only difference here. So we want to find f of 4 using the fact that f of 0 is equal to 3 as we did before. All right? Okay, so all right, so in this case, we need A and B. Let's call the smaller one A. So A is 0 and B is 4. We're looking at the arguments of our functions. Let's go ahead and write down FTC part 1. F of B minus F of A is equal to the integral from A to B of the of the derivative of f dx. Okay? All right, so let's substitute A and B into our function, into FTC part 1. So we have f of 4 minus f of 0 is equal to the integral from 0 to 4 of f prime of x dx. All right? F of 4 is what we're looking for. We already know that f of 0 is 3. That was an initial condition provided for us. Now, this integral right here basically represents the area, this area right here. See this area? The area between this semicircle and the x-axis. Okay? So what this basically is a rectangle. You have a rectangle. Okay, so that represents the that entire region. And then we are subtracting what? What are we subtracting from the rectangle? From the rectangle, we are subtracting a semicircle. Okay, so when you take a rectangle and you subtract a semicircle, you're going to be left with this region right here. Okay, so you can visualize it. Anyway, let's go ahead and write down our formulas. All right, so the area of a rectangle is length times width, and then we're going to be subtracting area of a semicircle, which is half of pi r squared. Okay. All right. So our rectangle, if you notice, is underneath the x-axis. Okay. So it will have a negative height. So we're gonna have or another thing we can do is we can just find the area and then negate the final result. I think that'll be easier to do. Okay. So the other way is correct too, but let me just do it this way. So we have 2 by 1, 2, 3, 4. 2 by 4. Okay, so the area is going to be 2 times 4 minus, what's the radius of the semicircle? The radius is 2, so it's going to be 1/2 pi 2 square. Okay, so the area, let me call this area of shaded. Okay, so the area of the shaded region is negative, so let me put it in red. The area of the shaded region is simply going to be 2 times 4, which is 8, minus 2 times 2 is 4, 4 over 2 is 2 pi. Okay, now this would have been the answer if the region was above the x-axis, but the area of the shaded is beneath the x-axis, so I will negate the entire result. Okay, so which basically becomes, what does it become? Negative 8 plus 2 pi. That's the area of the shaded region. So that's what we're going to insert right here for the value of this integral. Okay, so this is equal to the integral from 0 to 4 of f prime of x dx. Okay, so I chose to do it in this manner because I don't want to confuse the signs, especially when it involves multiple expressions. Just find the area and then put minus in front. You could do that. Okay, so if I insert it here, I will have negative 8 plus 2 pi. In order to get f4 isolated, you just simply add 3 to both sides. So f of 4 is negative 8 plus 3 plus 2 pi. And your final result, f of 4 is equal to negative 5 plus 2 pi. Okay? So don't forget to box your final result. Thanks so much for taking the time to watch this presentation. We really appreciate it. Don't forget to give us a thumbs up if you found the contents of this tutorial helpful to you. We really appreciate your positive feedback. Questions and comments, just place that below this video in the comment section and we'll be glad to respond to your concerns. Do subscribe to our channel for updates to the remainder of this review series. More clips can be found on math.circ.com. Thanks again for watching and have a wonderful day.